Welcome back, and today we're going to be doing a equity valuation. Okay, so you know what we're talking about. Unlike a bond, which is a debt security that promises coupons and par value at maturity, a stock or a share is an ownership security. It's an equity security that promises dividends and future price appreciations. Right? So we know that. Good. Well, let's start now. So. What finance is all about? Finance is about P0, and P0 is about D of future benefits, right? And the D operation boils down to the toolbox of time and R, of T and R. T is time, R is the price of time, right? The price of time, the discount rate or the price of time. Good. Let's start now. P0 is what? P0 is what? It's D of future benefits, right? So P0 is all about D of future benefits, right? We know this much. This is what all of finance is about. This is what all of finance is about. Finance is the big question of P0, and it's the big answer of future benefits, and it's the toolbox of D, which is T and R, which is what, Which is T and R. T, that's time, and R, that's the price of time. The price of time. Great. So for a bond, what we have here, for a bond, P0 was what? P0 was D of what? What are the future benefits for a bonds? We have coupons, right? So the future benefits are coupons, two types of benefits, plus what? Plus par value at maturity, right? So for a bond, we have two types of benefits. We have two types of future benefits. We have coupons and we have par value at maturity. And therefore, the price of a bond, P0, is nothing but the discounted value of coupons plus the discounted value of the par value promised at maturity. So we know that very well, right? For a share, for a stock, what we have, for a share, P0 is what? P0 is D, and D of what? How we think of it? Let's imagine that you're going to be purchasing the share now for P0, and you're going to be holding it for 1 year, right? You're going to be holding it for 1 year. So you're going to be cashing in for P0, but cashing out for how much? You're going to be cashing out for the expected value of P1, right? Because when you get out after 1 year, you're going to be entitled to the expected value of P1. And what? And the dividends in between. And what, And the dividends in between. So P0 is nothing but D of the first dividend, right? Of what, Of the first dividend plus the first price, or the expected price after 1 year. And this much is going to be defining our P0. So P0 is going to be nothing but the discounted value of D1 plus the expected price after 1 year. Of course, this is so since you're going to be holding the share for 1 year. So you're going to be cashing in for P0, but cashing out for the expected value of the price after 1 year. And of course, you're going to be entitled to the dividends in between. You got it? You're going to be entitled to the dividends in between. But how much is the expected value of P1? Let's apply the same logic again. The expected value of the price of P1 is nothing but D2 plus the expected value of P3, right? Right? This is correct? P2, I'm sorry. Let me take it back, I'm sorry. So it's going to be P2, D2. So it's going to be D2 plus the expected value of P2. And how much is P2? P2 is going to be what, P2 is going to be D3, right? Plus the expected value of P3. And how much is P3? This will go on and on until we get to what? Until we get to D infinity, right? Until we get to D infinity plus the expected value of P infinity. The expected value of P infinity. So I hope this is clear. I hope this is clear. Again, P0, let's imagine you're going to be holding the share for 1 year, and therefore, if you cash in for P0, you are expecting to be cashing out for the expected value of P1, and still you're going to be entitled to all the dividends in between. But how much is the expected value of P1? This is nothing but the second year dividend plus the expected value of P2. How much is P2? The expected value of P2. This is again applying the same logic. The third dividend plus the expected value of P3. How much is P3? It's going to be the fourth dividend plus the expected value of P4. And this will go on and on until you get to D infinity plus the expected value of P infinity. And I hope this is very clear. I hope this is very clear. So, where are we now? Where are we now? Again, where are we now? P0 is discounted future benefits. This is what finance is all about. It's about the big question of P0, and it's about the big answer of future benefits, and the toolbox of D, which is the toolbox of T and R. That's time and the price of time, which is R. For a bond, what are the future benefits? The future benefits were two types. We have coupons and par value at maturity. And therefore, the value of a bond is nothing but the discounted value of future coupons plus the discounted value of the future amount you are promised at maturity, which we refer to as par value. Now we come to a share. What a share is about? It's an ownership security. It doesn't offer benefits in the form of coupons or par value at maturity. Unlike a debt security, an ownership security does not expire. You got it? An ownership security does not expire. Therefore, the benefits are going to be different. So the benefits you are entitled to when you are investing in a stock come in the form of dividends and future price appreciation. Let's imagine a very easy, simple scenario. You're going to be purchasing the stock now. You're going to be purchasing the share now for P0, holding it for 1 year, and getting out after that 1 year. How much you're going to be receiving when you get out? You're going to be entitled to the expected value of P1, plus all the dividends in between. Plus what? All the dividends in between, which is the first dividend, which is the first year dividend. But how much is the expected value of P1? It's the second year dividend plus the expected value of P2. But how much is the expected value of P2? How much is the expected value of P2? It is the third year dividend plus the expected value of P3. And how much is the expected value of P3? It's going to be the fourth year dividend plus the expected value of P4. And this will go on and on until we get to D infinity, right? Plus the expected value of P infinity. Okay, so where are we? So P0 is what? P0 is going to be D of what? D of D1 plus D2 plus all the way up to D infinity plus the expected price at infinity, right? So this is what we have now. But how much is the expected price at infinity?
Zero.
It's 0. How much is the expected price at infinity? It's 0. Why? We have two reasons. A mathematical reason. First, there is nothing to discount after infinity. There is no future after infinity. This is why the price at infinity is 0. The economic reason is that no one is going to be willing to pay anything for something to be delivered at infinity. You got it? So we have two reasons here. A mathematical reason, and this has to do with the fact that there is no future after infinity, and therefore there's nothing basically to discount. The second reason, which is an economic reason, has to do with the fact that it's worthless. Nobody's going to be willing to pay anything for something to be delivered at infinity, right? So let's continue. P0 is going to be what now? It's going to be D of what, D of D1 plus D2 plus all the way, right, up to D infinity, right? And of course, the expected price at infinity is going to be 0. This is why it disappears from here. So we stop here with a couple of assumptions. We stop here for a couple of assumptions. We stop here for a couple of assumptions. The first assumption is what? The first assumption is what? Dividends. Dividends grow at a constant rate G. So dividends grow at a constant rate G. This is the first assumption. The second assumption is that R, or KD, is always constant. R is always constant. So we have a couple of assumptions. First, dividends will always grow at a constant rate G. And the second assumption is that R is always constant. R is always constant. So I hope this is clear.
The first assumption.
Yeah. Dividends will grow at a constant rate G. Dividends will grow at a constant rate G. So the growth rate is going to be constant, and we call it G. Okay, we call it G. The second assumption is that the discount rate is always going to be constant. It is not going to be changing across time. It is always going to be constant.
So that means it will always be G?
The growth rate is going to always be G, and the discount rate is going to always be R. You got it? And those are constants. So let's continue. So where are we now again? P0 is the discounted value of future benefits. For a bond, we're talking about coupons and par value at maturity. For a share, we're talking about dividends and price appreciation, right? Good. So P0 is going to be the discounted value of all dividends up to infinity plus the expected value of price at infinity. But the expected value of the price at infinity is 0 because there is nothing to discount after infinity. There is no future after infinity, and this is why this price is 0. So we're going to be ended up with all the dividends up to infinity. We stopped with a couple of assumptions. First, dividends will grow at a constant rate G, and the discount rate is always going to be a constant R. Now let's continue. So P0 is going to be what now? P0 is going to be what? It's going to be D. It's going to be D. It's going to be D1, right? It's going to be what? D1 discounted. But what's D1? What's D1? It's D0 times 1 plus G, right? Right? Let's discount that 1 year backwards. So we have to divide by 1 plus R. 1 plus R, right? Right? So this is now discounted. This is now discounting the D1, right? This is now discounting what, This is now discounting the D1 because what's D1 according to those assumptions? D1 according to those assumptions is what? D1 is going to be what? It's going to be D0 times 1 plus, 1 plus G, right? According to those assumptions, D1 is going to be what, D0 times 1 plus G, right? And this is what we have here for D1. It's D0 times 1 plus G. Let's go ahead and discount it. It's going to be D0 times 1 plus G over 1 plus R, right? Let's go ahead and discount D2. So D2 is going to be what?
D1.
D2 is going to be what,
D0.
It's going to be D1, bravo, times 1 plus G squared, right? 1 plus G to the power 2 over 1 plus R to the power 2, right? Right? Plus, this will go on and on. This will go on and on until we get to D infinity, right? Or D0 times what, Times 1 plus G to the power of infinity over 1 plus R to the power of infinity, right? right? So now let's define, of course.
The second one.
Yeah.
D1 or D0?
The second one is D0. Sorry, made a mistake. It's D0, of course. We're expressing everything in terms of D0. But it's D2. Why? Because D0 times 1 plus G to the power 2 is D2. You got it? So we're expressing everything in terms of D0. Let's now define 1 plus G over 1 plus R as U. Sorry, I'm So let's now define 1 plus G over 1 plus R as U. Now, what are we going to be having? Let's go ahead and express P0 in terms of U. So what are we going to be having? It's going to be P0 equals what, huh? D0U, right? Plus D0 U squared, right? Plus all the way up to D0 U to the power of infinity. D0 to the power of infinity. Whenever we are working with infinity, we have to entertain some kind of mathematical trick. My mathematical trick is to multiply P0 times U and then take it back. You got it? My mathematical trick is to invent P0 times U and then take it back again, right? So let's go ahead and do that. So P0 times U is what? P0 times U now is what? It's going to be D0U times U, which is D0 U squared, right? Plus D0U to the power of 3, right? Plus all the way up to D0 to the power U to the power of infinity plus 1, right? So this much we're going to be having. Let's go ahead and take off P0U out of P0. Let's see. Are you on here? Are we on the same page so far? Okay, so let's go ahead and define P0 minus P0U. This is going to be what? Well, if you were to define P0 minus P0U, well, you're going to be ending up first with D0U, right? From the first equation. You're going to be ending up with this part from the first equation, right? And those middle parts are all going to be canceling off, right? And you're going to be ending up with the negative sign of this part from the second equation. You got it? You got it? Because you're subtracting, right? Because you're subtracting. So we're going to be ending up with D0U minus D0 U to the power of infinity plus 1 to the power of infinity plus 1, right? So let's go ahead now and solve for P0. How can we do that? So we can factor out the P0. P0 times 1 minus U. And that would be what? We can go ahead and factor the D0U from here. So this is going to be what? D0U times 1 minus U to the power of infinity. To the power of what, huh? To the power of infinity, right. Okay, and let's go ahead now and replace the U. So P0 again is going to be what? P0 is going to be what? D0U times 1 minus U to the power of infinity over 1 minus U. Over what, huh? Over 1 minus U, right? Right? So let's go ahead and work with U. So P0 is going to be what in terms of U? In terms of U, we're here. P0 equals D0U times 1 minus U to the power of infinity over 1 minus u. Let's go ahead and replace 1 plus g over 1 plus r for u. So what we're going to be having here, d0 times 1 plus g over 1 plus r times what, times 1 minus u to the power of infinity, which is 1 minus 1 plus g over 1 plus r to the power of infinity, right? And this is all over what, This is all over what? Over 1 minus u, which is 1 minus 1 plus g over 1 plus r. Okay? So if you solve out the denominator, what are we going to be having? If you solve out the denominator, what are you going to be having? You're going to be having the denominator, you're going to be having 1 over r. And here you're going to be having 1 plus r minus 1 minus g. Right? Right? And over the denominator, you're going to be having what? You're going to be having what? You're going to be having d1 times 1 over 1 plus r, right? Right?
Yeah.
Times what? Times that term, which is 1 minus 1 plus g over 1 plus r to the power of infinity. Okay? Now, this 1 plus r is going to be canceled out with that 1 plus r, right? Right? And what are we going to be ending up with here? So P0 is going to be what again? P0 is going to be what?
D1.
P0 is going to be d1 times 1 minus 1 plus g over 1 plus r to the power of infinity. And the denominator, the positive 1 is going to be flying off with the negative 1. You're going to be ending up with r minus g, right? Right? So what are we going to be having again? It's going to be d1, right? Times what? Times 1 minus 1 plus g over 1 plus r to the power of infinity, right? Over r minus g. Okay? And my question here, we're almost done. My question is, what must hold for that expression to make any sense? What must hold for that expression to make any sense? Think about it. Well, we're talking about pricing. We're talking about a price, and a price, by definition, is non-negative. A price can be 0, it can be positive, but it cannot be negative. A price is non-negative. And therefore, what must be holding for that expression to make any sense is that r must be greater than g. Only when r is greater than g, P0 is non-negative, which is correct, which is consistent. So only when r is greater than g, P0 is non-negative. P0 is non-negative, which is consistent. Now let's go ahead and solve it. So P0 is going to be what? We're almost done here. So P0 is going to be what? Well, of course, it's going to be what? Well, think about it. Whenever r is greater than g, 1 plus g over 1 plus r is going to be less than 1, right? Whenever you raise anything less than 1 to infinity, the outcome is going to be 0. It's going to be what, It's going to be 0. The logic here is very simple. Ever since r is greater than g, and this is the only way via which this expression is going to be a sense maker, that ratio is going to be less than 1. And whenever that ratio is going to be less than 1, that term is going to be 0, because anything less than 1 raised to infinity is going to be 0. And therefore, 1 minus 0 is going to be 1. 1 times d1 is going to be d1. And we're going to be having d1 over r minus g. This is a very important model in financial economics. In case we in particular, we do have a name for it. We call it the Gordon growth model. The Gordon growth model. We call it the Gordon growth model. So this is a very profound model in finance. This is how we evaluate equity securities very basically. So in very basic terms, this is how we evaluate equity securities, okay? The Gordon growth model. So let's now see some examples on Gordon growth model. Let's now see some examples on Gordon growth model. So what were the assumptions implicit in the model? What were the assumptions implicit in the model? Constant G and constant R. And of course, in order for the model to make any sense, R must be greater than R must be greater than G. R must be greater. D1 here, that's the first year dividend, right? This is the first year dividend. You got it? This is the first year dividend. And R, this is the discount rate. It's always constant. It's always going to be the same. And G, that's the growth rate, and it's always going to be the same, right? Yeah, let's see some examples. Let's see some examples. P0 is how much? P0 is how much? P0 is how much? If the first year dividend, is expected $10. R, the discount rate is 8%, and G, the growth rate is 6%. So how can we do it? How can we think of it now?
8%?
Yeah, how can we think of it now? So P0 is how much? P0 is how much? If the first year dividend is expected $10. So what's the first year dividend?
D1.
It's D1. It's what, huh?
D1.
It's D1, right? And therefore, an R is what? R is G, right? And G is what? And R is 8%, and G is what? 6%. So how much is P0? P0 is going to be what?
D1.
P0 is going to be what? P0 is going to be D1 over R minus G, right? Let's write it down. D1 over R minus G. Now you know why, right? Now you know why, right? Now you know why this is so, right? And you know the implicit assumptions there, right? You know why this is so, and you know the assumptions behind it too. What are the assumptions? Constant R and constant G. And this is not always the case, of course. This is not the case at all in reality. In reality, R changes and G changes. In reality, both R and G are not constants. But this is what models do for us. What models do is that they simplify reality. You got it? They simplify reality. And I hope this is clear. So let's apply that. So this is going to be what? 10 over 8 minus 6%, which is what?
2.
Which is 2%. Which is what, huh?
2%.
Which is 2%. And the answer is going to be? It's going to be $50. It's going to be what? It's going to be $500, right?
50.
Is it 50 or 500?
50.
Well, 50 times 20% is 10. 500 times 2 is $10. It's going to be $500. The answer is going to be $500. And I hope this is clear. It's going to be 500.
500.
500.
Could you repeat it?
Of course. Of course. Okay. The first year dividend is expected $10, right?
Yes.
So D1 is how much?
It's D1.
D1 is $10.
Yes.
R is how much?
8%.
G is how much?
6%.
So $10 over 8 minus 6%, which is 2%, and 10 over 2% is what?
So the difference between...
It's $500, right?
Yeah,
You see that?
Yes.
So 10 over 2% is $500. You got it now? Any questions, Mansour? This is fine now? Good.
So
Yes?
Like the dividends within the first year, 500.
The dividend in the first year, yeah, the first year dividend is expected $10.
$10.
Yeah, it's expected value. It's $10. It's an expected $10.
Include the dividends and the benefits, 500.
No, it's just the dividend. Just the dividend. 500 is the price. 500 is the expected P0. Oh no, not the expected. It's P0.
So the total P0 plus 500.
No. P0 is 500.
500.
Okay, so we're here. P0 is what? D1 over R minus G.
The total.
P0, I'm after P0. I'm solving for P0. So what do I have? What do I have to have in order to solve for P0? I have to have D1, R, and G. Now D1 is what?
10.
R is what?
8.
G is what?
6.
So 10 in the numerator over R minus G in the denominator, and the answer is going to be 500. You got it? Does that answer the question?
P0 will equal 500.
This is the price of the stock. The price of the stock now. So for example, if you want to purchase a Microsoft stock now, for example, or yeah, if you want to purchase like an NCB stock now, and you expect the first year dividend to be $10, right? You expect the dividends to grow at a constant rate 6%,
So this is all.
and you expect the discount rate. Of course, investments are all about expectations. But let me continue. And you expect the discount rate to be 8%, or you have a discount rate of 8%. Therefore, you should pay $500 for that share. You should pay $500 for that share. If you pay less, it's a good opportunity. If you pay more, it's a bad investment.
So this is
This is an intrinsic value.
before buying.
Yeah, this is an analysis before you buy. Yeah, well, it depends. Well, you may think of it like ex ante or ex post, but normally we think of it ex ante before you purchase, before you do the actual investment. You got it?
My question in the beginning, after 1 year,
Yeah.
you will get the dividends and plus the price that you pay, right?
Yeah. But we proved it. We proved it here that nothing matters. Nothing matters except for the first year dividend. Nothing matters because we proved it. We proved it all the way, right? We proved it. We started up with all the dividends, right? We started up with all the dividends, right? All the dividends and even the price at infinity. And we came down to the fact that nothing matters except for the first year dividend. You got it?
RNG.
We proved it. Nothing matters except for the first year dividend on
So
RNG.
that's the price of the share.
Exactly. This is the price of the share. This is the price.
So RNG, I mean D1 and RNG are given.
Of course, I'll also, yeah, you're going to be given, let's see another exercise, no problem. Let's see another exercise. So, okay, so for example, P0 is 500. Now I'm giving you P0, right? Right?
Okay.
The first year dividend is $10. The first year dividend is $10, right? And R is 8%. And now let's go ahead and solve for G. Let's go ahead and solve for G. How can you do it? It's the same problem. How can you do it?
So
Let's go ahead and solve for G.
it will be 10 over.
Of course, yeah. So let's see what we have. So we know right on that what we know. We know that 500 equals what? Equals what? Huh?
10
Equals 10 over
8
8%.
yes,
Minus G.
Minus G. And we can solve for G. And so G is going to be what? And so G is going to be what?
500.
And so G is going to be what? If you do the math, G is going to be what? Well,
100. 8
Huh?
out of
G
500.
well, it's going to be, okay, well, it's going to be 500 times 8%, which is how much?
Over 10.
Which is what? 500 times 8%. This is 40, right? 40. So 40 minus 500G, right? And this is gonna be 10 minus 40, right? And 500G is gonna be what? So we're going to be dividing by 500, right?
Yeah.
We're going to be, I'm sorry, so we're going to be dividing by 500, right? But the numerator is going to be what? The numerator is going to be what? It's going to be 30. It's going to be like negative 10 plus 40, right? Is it? It is. It is going to be negative 10 plus 40. So it's going to be 30 over 500, which is what? Which is 6%.
Why plus 4?
I just solved it. I just solved it algebraically.
That's what
Yeah, of course. It's going to be 6%. It's going to be 30. Why 40? Because 500 times 8%. We cross-multiplied.
Okay.
We cross-multiplied, right? We cross-multiplied, and therefore it's going to be 30 over 500, which is what? Which is 6%. So we're done.
We'll do the same if we're solving for R.
Let's go ahead and do it. No problem. Why not? Let's go ahead and do it. Let's go ahead and do it. So any questions here, guys?
Just want to write this down.
Yeah, any questions? You have any questions, Mansoor?
The last step,
Yes, no problem. I just cross-multiplied.
500 with the 8%.
500 times 8%, that's 40, minus 500G.
Can you please write it down, all details?
Yeah, of course, no problem, no problem. So it's gonna be 500 times the 8%, right? Right? 500 times the 8% minus 500G, right? Equals what? Equals 10, right?
Yeah.
And now minus 500G is gonna be what? Is gonna be what? Is gonna be 10 minus 40, right? Which is minus 30. Which is what, huh? Minus 30, right? Now the minus will fly off with the minus, and therefore G is gonna be 30 over 500, which is 6%. You got it? So any questions here? I cross-multiplied. So let's do it again. What if P0, is still 500? What if P0 is still 500? Huh? What if P0 is still 500? The dividends expected for the first year is still $10. R is missing, but G is 6%. So how much is R before we solve it? How much is R before you solve it? R is going to be 8%. Dividends expected. Dividends expected. I'm sorry, it's. I'm sorry, it's just the problem with the expected. Yeah. So how can we go about it here? How can we solve for it? So we go ahead and solve for it the usual way. So how are we going to be going about it? So again, we know that 500 equals what? We know that 500 equals what? We know that it equals 10, right? Over R, which is missing, minus 6%, right? And therefore, the R is going to be how much?
8.
The R, of course. Why? Because it's going to be what? It's going to be negative 6% times 500, that's negative 30. So it's going to be 40 over 500, which is what? Which is 8%. Which is what, huh? And of course, I did it by cross-multiplying. You got it? I did it by...
50 over 500, that's 10%?
50 over, of course. Bravo, bravo. 50, of course, yeah, of course, yeah, bravo, of course. So any questions here, guys? We have any problems? Let's do another problem. Do you have any questions? Forgive me for the proof. I know, it's my fault. I apologize.
And
Previous screen, Doctor. Previous.
that's 50 then?
What?
Previous screen.
Before the R.
Okay,
Yeah, okay.
just cross-multiplied.
Before the G?
Here,
No.
here,
Yes. And what?
and so.
And so.
Yeah, and so. So I hope this is clear. Do you have any questions so far? So let's go ahead and see another exercise. And I hope I'm making myself any clear here. And forgive me about the proof, but I always like to teach my students the logic behind things. Okay? I don't like to come up here and just like tell you like how things are without teaching you the logic behind it. You're graduate students and you are entitled to learn the logic behind things. And you can too. You're smart guys, so you can learn the logic. Any questions? Okay, so let's continue. Let's continue.
Take an example.
Yeah. Could you please find out like how much is 10 over 1.06 for me? How much is 10 over 1.06? 10 over 1.06 is how much? 1.06. 9.43. Great. $9.43. 9.43. Great. Good. So let's continue. Let's continue.
10 minus 40
Yeah.
equal minus 30, right?
Right.
Okay. How we change it to...
Because minus 30 and minus a negative 500. So they two fly together. Okay, so P0 is how much? P0 is how much if dividends now, dividends what, huh? Dividends now is 9.34, $9.34. R is a 8%, and G is 6%. How can we solve it? How can we solve it?
Right equation first.
Well, dividends now, watch out. Watch out. Dividends now. This is not D1. This is D0. This is what, huh? D0. Because what's now in finance is times 0. You got it? What's now in finance times 0. So watch out. You're not given D1. This is not D1. This is D0. So how can we go about it? We know that P0 is what, huh? We know that, huh? We know that P0 is what, huh? Is D1 over R minus G, right? But I don't have D1 from here, right? What I have is D0. But D1 in terms of D0 is how much? D1 is nothing but D0 times 1 plus G, right? So what we have in the numerator is D0 times what, huh? Times 1 plus, huh? 1 plus G, right? Right? Over R minus G. Let's go ahead and apply that. So D0 is how much? 9.34. When you multiply it by 1 point G, this is going to be what? This is going to be 1.06, right? Right? Because G is 6%, right? So 1 point G is going to be 1.06. Over what? Over R minus G, which is 8% minus 6%, which is 2%. And the answer is going to be what? Guess what? The answer, the numerator is going to be $10. $10 over 2% is still going to be the $500.
Can we go over it again?
Of course, of course. Here in this problem, you're not given D1. You are given D0, right? But the Gordon-Groth model was based on D1. So you have to go through D1 from D0. Yeah, I'm sorry, you have to go through D0 in order to get to D1, in order to get to D1. So how can we possibly get to D1 from D0? We'll just take D0 and multiply it up by 1 plus G. When you do that, you're going to be going home with D1, and D1 over R minus G is going to be $10 again over 2%, which is the $500. You got it? It's the same concept, but remember here in that example first. In that example, for example, well, in the previous example, what we had the first year dividend. The first year what, huh? Dividend. Now what we have, we have dividends now. We have what? Dividends now, right? So first we have to get to the first year dividends from the dividends now. And how are we going to be doing it? We're going to be multiplying it by 1 plus g. Watch out. Watch out whether you are given the dividends now or the dividends 1 year ahead. If you are given the dividends 1 year ahead, no sweat. Take it and plug it into the Gordon graph, and you're going to be going home with P0. But if you are given the dividends now, you have to do something about it first. You have to convert it to D1. How are you going to be converting it to D1? You take it and multiply it up by 1 plus g.
Okay, doctor.
Of course, yeah.
What
Yes,
about
sir.
dividends for second or third?
Great question. Thank you so much. So let's see. Great. Nice question. Nice question. Nice question. So for example, could you please find out about, Ahmed, could you please find out about 10 times 1.06 to the power 2 for me? 10 times 1.06 to the power 2. This is going to be how much? 1.06 to the power 2 times 10. This is going to be what?
11.236.
11.23. Great. Let's see how. Let's answer to your question. This is going to be a nice question. So let's answer to your question. P0 is going to be how much? P0 is going to be how much? Right? If the second year dividends, so the second year dividend, I'm sorry, just do it here. So the second year dividend is expected, is what, huh?
11.
Is expected 11.23, $11.23. So if this much is expected for the second year dividend, R again is 8%, and G is what, huh? 6%. Now what are you given here? What are you given here? Are you given D0, D1, or D0?
D2.
So what we have, how can we possibly spell out the price? How can we possibly decide on the price? We know how, Gordon graph. And this is what we have for Gordon graph. P0 equals what, huh? D1 over, huh? R minus G, right? But what we have here is not D1, right? What we have here is not D1. We have D2. We have what, huh? We have D2. But D2 is how much? So I know that D2 equals nothing but D1 times what? Times 1 plus G. Bravo.
Yes.
Bravo. Bravo. And therefore, D1 is going to be how much? And so D1 is going to be what? D1 is going to be D2
Over 1 plus g.
Thank you so much. Great. You got it. You got it. You got it? So D1 is going to be D2 over 1 plus G. You got it? It's the same concept. You can play with it. You can play with it whenever you please, whatever you please. You got it?
Yeah.
So now D1 is going to be how much in this case? In this case, D1 is going to be how much?
11 point.
It's going to be 11.23 over?
1 plus.
Over 1.06, right? Which is 1.0 G, right? 1 G. And this is going to be how much? Guess what? It's going to be $10 again. Is it? Yes, it's going to be 10. Well, I'm sorry, no.
0.5.
It's going to be what?
10.59.
No, how much is it? I want to make it 10. So let me change that. Let me change the dividend. So dividend now. Okay, so just tell me 10 times 1.06 is how much? 10 times 1.06. Huh?
10.6.
10, of course, 10.6. 10 times 1.06 is 10.6. And therefore, let's have, just make it nice looking here, the mathematics. So let's make it 10.6. So the second year dividend is expected 10.6. Yeah. Just want to make it look nice. So it's expected, sorry here, it's expected 10.6. And of course the answer is going to be what? It's going to be 10, right? Now we have D1, which is 10. 10 over 2% is what, huh? Is $500. Is what, huh? The same. You got it? The same idea. You got it? You got it? Let's solve it another way. Let's see another example. What if the 5th year dividend is expected? What if the 5th year dividend is expected? What if the 5th year dividend is expected? You're expecting the 5th year dividend. How can you go back and decide on P0? So could you please multiply 10 by 1.06 to the power 4? Multiply 10 by 106 to the power 4. This is going to be how much? 12.64. Great. So let's see this nice example. P0 is how much? P0 is how much? If the 5th year dividend, the what, huh? The 5th year dividend is how much? The 5th year dividend is expected how much? Is expected 12, huh? 12, huh? 12.62. $12.62. R is 8%, right? G is how much? G is 6%. Let's go ahead and decide on that. Okay, what we know? What we know? The Gordon growth. What we know, huh? The Gordon growth. What we have for the Gordon growth? P0 equals what, huh?
D1.
P0 equals what, huh? D1 over R minus G. I don't have D1 here. What I have?
D5.
I have D5. I have what, huh?
D5.
I have D5, right? But D5 is how much D1? How much? Okay, so let me take it easy here. Just a second. So D5 equals what? D5 equals what? Equals D0 times what? Times 1 plus G. No, to the power 5, because we're talking about D0 here, right? Right? But what's D0?
D1.
What's D0? It's D1 over 1 plus G, right? Right?
Yes.
So this is D0, right? Times 1 plus G to the power of 5, right? 1 plus G is going to be canceling off here. And you're going to be ending up with D1 times 1 plus G to the power 4. Bravo. You got it? You got it? So given D5, how much is D1? And so D1 is going to be what?
D5
It's going to be D5 over what? Over 1 plus G to the power of
4.
Thank you. Thank you so much. You got it? You got it now? So let's go ahead and apply it. You got it? I hope this is clear.
D2.
Is it, Masur?
I want to see D2.
Huh?
The screen with the D2.
Of course. Here. 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 You want to see it here? Here.
Just the last one.
Where?
Where are we?
So here, you want to see it here? D5, this is the problem now for the first year. This looks like a mess here.
Yeah.
The last one.
This is the problem, right? Right?
It's 5.
Okay, so
We need 2. Yeah, this one.
this one here? Good. So I hope this is clear. You have any questions? Huh? Okay, and let's go ahead and solve it. Let's go ahead and solve it.
Sorry.
No problem. Let's go ahead and solve it. How can we solve it?
I got D1.
First, we have to solve for D1, right? So we're fine here. You're done, Bahamdeen?
We're just trying to.
Fine, Masur. Fine now.
That's okay.
Okay, guys, so I guess we're doing well so far. So let's go ahead and solve it.
This one.
So, yeah, this is what we have now. And,
D5 is 12 point.
of course, so D5 is given. It's 12.30 what? 32.
2, 4.
It's 12 point, how much is D5?
12.62.
D5.
12.62.
Where is it?
What is this message?
We lost it, right? I have? Have I erased it?
No.
And maybe sit down.
Yeah, it's here, right here. Yeah, no problem. So D5 is 12.62, right? D5 is 12.62. And therefore D1 is going to be what?
D5.
D1 is going to be what? It's going to be D5 over 1 plus G to the power 4, right? Which is going to be D5, right? D5, what's an elegant way to put it? It's going to be D5 times 1 plus G to the power of
Minus.
negative 4 over R minus G, right? Now tell me, how much is D5? How much is D5 times, it's going to be $12.62, $12.62
Over 2%.
times 1.06 to the power of negative 4 over 2%. And guess what? It's going to be $10 over the numerator, over 2% in the denominator, and the answer is going to be still our very nice looking friend, $500. You got it? So this is a neat outcome, the $500.
Can you please go to the slide before this?
It's a lot of them.
This one here?
Yeah, that's I just ended to write.
Of course, take your time.
Yeah.
Why is 1 plus G in the power of minus 4?
Because,
We are going from D5 to D1?
no, D5, it's to the power of negative 4.
Yeah.
To the power of negative 4, it's as if you are dividing by 1 plus G to the power 4.
Ah,
You got it?
yeah.
Okay.
I'm sensing that.
No, it's okay. We all do. We'll just try. Any questions here? Any problems? Huh? Okay. Let's see. Yeah, you have enough for today? Mansoor had enough for today. Okay, I'll let you go for today. No problem. No problem. I guess you had enough for today. Do you have any questions before we leave, guys? Huh?
Just down it, negative 4, sorry.
What? Negative 4. Because it should be D5 over 1 plus G to the power 4, which is D5 times 1 plus G to the power negative 4. Why? Listen up. Y over X equals Y times X to the power negative 1. You got it? You see that? Good. I hope this is clear. Yeah?
Could you back?
Explaining with D5.
The last one.
Here? Well, in general, let me give you a general expression for it. Let me give you a general expression for it. Let me help you here, Ahmed, and give you a general expression for it. In general, dn is going to be what? In general, dn is going to be what?
D0.
It's going to be d0 times how much, Mansoor?
1 plus.
Times how much, Mansoor? Times?
In.
No, times 1 plus g to the power of how much, Mansoor? To the power of n. Right? Right? But dn, again, is going to be how much in terms of d1? So in terms of D1, it's going to be how much?
D0.
It's going to be D1. You're going to be adding an index of 1 here, right? Right? And taking 1 from the n power here. You got it? So it's going to be D1 times
1 plus G.
1 plus G to the,
1 minus N.
to the power of n minus 1.
Or N minus.
You got it? To the power of n minus 1, right? You got it? You see that? This is in general. So D8 is going to be what? It's going to be D0 times 1 plus G to the power of 8. And it's going to be D1 times what? 1 plus G to the power of 7.
Oh, okay.
D1 times 1 plus G to the power of n minus 1.
8 minus 1.
Yes, sir. You got it?
So,
Yeah.
if D1 is D2, so
Okay.
it's going to be N minus 2.
You want to go like you want to do what? So you want to solve for what? You have like what? You have dn and you want to solve for d1?
No.
Okay, you have dn and let n be 2. No problem. Let n be anything. And so d1 is going to be what? We solve back for d1. It's going to be what? It's going to be dn, right? dn over 1 plus g to the power of n minus 1, right? Right? To the power of what? To the power of n minus 1, right? Right? Which is what, again? Which is dn.
Whatever the number is.
Which is dn times 1 plus g to the power of the negative of n minus 1. You got it? But it's an index. You see that? So I hope this is clear, and if you have questions, please ask me. If you don't, yeah?
Just if you can go back to the second year.
Of course. Here? Where?
The 5th year is.
The 5th year again?
Before that.
Here?
The second year.
Yeah,
The 2nd year? Okay.
we can, if you can.
Of course,
take
of
it,
course. Of course.
Step by step.
Of course, of course. The 2nd year dividend is expected 10.6, right?
Okay.
So now, how can we get to the 1st year dividend from the 2nd year dividend, right? Well, we know that the 2nd year dividend, equals the 1st year dividend times 1 plus g, right? Right? We know that, right? To the power of 1, right? To the power of n minus 1, which is 2 minus 1, that's 1. You got it? You got it? Okay, we have here what? dn equals what? dn equals what? d1 times 1 plus g to the power of n minus 1, right? And now we have what? Where is the problem?
Before.
And this
Yeah, now we have what? dn. So dn equals d1 times 1 plus g to the power of n minus 1. How much is n? It's 2. So d2 equals d1 times 1 plus g to the power of n minus 1, which is 2 minus 1, which is 1. You got it? Now you have d2, and you're going to be solving for d1. So d1 is going to be what? Here, Hamdain, is going to be d2 over 1 plus g. d2 over 1 plus g, right? When you do that, you're going to be ending up with what? You're going to be ending up with $10 for the D1. You're going to be ending up with $10 for the D1. Take the $10 and plug it into the Gordon growth, and you're going to be going home with the $500 for P0. You got it? Any questions? Any more questions?
Thank you.
Huh? Okay, so I'll see you next week.